So welcome everybody to this latest video on 162 Maths, and in this video we'll be focusing on algebraic fractions where we are asked to simplify algebraic fractions where we are adding and subtracting. Now when simplifying two algebraic fractions are either being added or subtracted, we are basically asked to find the answer as an expression and simplify it if possible. Now the key thing to remember is that although we are dealing with algebraic expressions, we are ultimately still dealing with fractions. So when adding or subtracting, we add or subtract the numerators, keeping the denominators the same if the denominators are the same, or we find a common denominator when the denominators are different before adding and subtracting the numerators. So looking at this general notation, as you can see in the first one, so when the denominators are the same, all we need to do is simply add or subtract the two numerators. And again, depending on what symbol you've got. Now the plus minus just basically means that when you're adding and subtracting, it basically means the same. So you could be adding or subtracting. Now when the denominators are different, as you can see here, we've got one denominator which is b and the other denominator which is d. Then what we need to do is find our common denominators. Now typically, one way of finding a common denominator is simply by multiplying the two denominators together, and that will automatically give you a common multiple. However, it might not be the lowest common multiple, but it certainly will give you a common multiple. And then from there, we then need to simplify where possible. Now, one way that you may have been taught on going from, let's say, this stage to, let's say, this stage is by doing the following multiplication. So first thing we're going to do is we're going to multiply these two numbers here, and that will give us our common denominator. Now to help with our numerator, what we need to do is basically multiply these two things together and then multiply those two things together. And that would, both the yellow and the green expression will give us our numerator. And obviously we are adding, subtracting depending on what symbol you have got in the middle. Now the best way to kind of translate this is to basically go through some examples, which is basically what we're going to be going through onto next. So let's have a look at these first three examples. And so for the first one, as you can see, we've got a algebraic fraction being added to a whole number. Now for this, what we want to try and do is, obviously we want to try and convert it so that it is a fraction. So what we're going to do is, if you have got a whole number or a whole expression, then just simply have it over 1 and you'll therefore have two fractions. And again, that also applies when you're subtracting as well. So with this, you can see here we haven't got a common denominator. So what I need to do is I need to convert this second fraction so that it's got a denominator of 5. And what I'm going to do then is multiply the 4 by 5 and multiply the 1 by 5. So what I'm then going to have is x over 5, which is the first fraction untouched, and then I'm going to have 5x. Well, no, I'm not going to have 20. And of 20 over, and then it's going to be 5. Now here, as you can see, the denominators are the same, so all I need to do is simply add the two numerators together. So I'm going to get x plus 20 over 5. And can I simplify that? No, I'm just going to leave it as it is. Now if there is a way you can simplify it, you can simplify it by writing x over 5 plus 4. But again, we're just going to keep that the same, but ultimately that will ultimately just give us the actual question, so that defeats the object. So this here would be your correct answer. So moving on to question 2, again, what I'm going to do is we've got a whole number, so I'm going to convert that as a fraction. So what I've got then is I'm going to multiply this fraction by the other denominator, which is x minus 2. I'm going to multiply that by x minus 2. So I'm going to have 4 lots of x minus 2, and again using brackets. And at the bottom I'm going to have x minus 2. And I'm going to keep the second fraction completely untouched because my denominators are now the same. So multiplying this out, and I'm going to multiply this bracket out. Now again, I would leave the denominators the same. So if you have got brackets, I strongly recommend that you do leave that the same. But here we're going to have 4x minus 8 minus 5 over x minus 2. And simplifying the numerator, I'm going to end up with 4x minus 13 over x minus 2. And then I can just check to see if I can simplify that. No, I can't. So that there is my final answer. Then moving on to question 3. Again, here you can see that my denominators are the same. So all I need to do is just simply add the two numerators together. And again, x just stays the same. It doesn't become 2x or x squared. Then all I'm left with is just x over 8. So let's have a look at the next three examples. So with question 4, you can see I've got a denominator of 2y and the second denominator is just y. So what I'm going to do is I'm going to multiply this second fraction by 2. And so what that then becomes is 1 over 2y plus, and it's going to be 14 over 2y. So now my denominators are the same. I'm going to end up with 1 plus 14, which is 15, over 2y. Quick check, can I simplify that? No. So that then is my final answer. Looking at question 5 again, I've got two different denominators. So what I'm going to do is I'm going to do 6 times 6x over 24k squared plus 5 lots of 4k over 24k squared. Now I could have easily just multiplied by, let's say, the first fraction by 6 and the second fraction by 4 and having a common denominator of 24k. But again, depending on how you want to work, it should still give you the same answer. So here we've got 36k plus 20k over 24k squared. And again, adding the two numerators together, I get this. Now from this I can cancel down. I can cancel 56 over 24, which goes into, it's going to be, well, I can divide both numbers by 2. So that's going to be 28, and that's going to be 12. And then again, I can simplify that by dividing by 2 again. So that's going to be, or divided by 4, I should say. So that's going to be 7, and that's going to be 8. And then I can cancel a k from there, leaving me with 7 at the top, and it's going to be 3k at the bottom. Now again, with this, if I just thought, well, let's just multiply it by 6 and 4, and if I multiplied, let's say, this by 6 and that by 4, then what I'd get would be 36 over 24k plus 20 over 24k, and then I'd get 56 over 24k. Then all I'd then need to do is divide the top and the bottom, the numbers, by 8. So I'd get 7 and 3, in which I'd get the answer of that. So again, depending on how you're multiplying, whether you're doing long multiplication or not finding the lowest common multiple, again, or if you're not finding the lowest common multiple, you just have to do some simplifying at the end. More chance of doing that than thinking simple with the lowest common multiple. Now with question 6, again, what I'm going to do is I'm going to multiply the first fraction by the second denominator and the second fraction by the first denominator. So here I'm going to multiply this both by x plus 2. And I'm going to multiply this fraction by 8. So looking at the top one, I'm going to have x, and I'm going to have x plus 2 over 8x plus 2 plus, and then I'm going to have 8 over 8x plus 2, and then multiplying out the top, I get x squared plus 2x plus 8 over 8x plus 2. Now again, a strong, definitely a useful tip is, yes, expand the brackets on the numerator, try not to expand the brackets on the denominator. Again, because what you want to try and do is see if the top factorizes, and then if it doesn't, then that will be your final answer. So looking at the top then, what I'll do is I want to see if this quadratic expression simplifies, in which it does not, because I've got 4 and 2, I've got 8 and 1, so no, that's not going to simplify, and I can't cancel out any terms, so that there would be my final answer. And again, just a little tip, do not expand denominator brackets. So looking at our next two examples, so again with this fraction here, I'm going to multiply all of this by y plus 2, and I'm going to multiply this second fraction by y minus 1. So looking at this then, what I'm going to end up with is 3 lots of y minus 1 over y minus 1 y plus 2, and automatically change that minus, so we've got a minus there, and I've got 1, and then y minus 1 over y minus 1 y plus 2. Again, adding the numerators together, I've got 3 bracket y minus 1 minus 1 y minus 1 over y minus 1 y plus 2. Again, leave the denominators factorised in brackets, but I'm going to expand the top. And again, you just need to be careful of the minuses when you are subtracting these two fractions. So here I've got 3 times y, which is 3y, minus 3, minus 1y, and then minus 1 times minus 1 gives me plus 1. And I've still got y minus 1 plus 2. So then simplifying the numerator, I've got 2y, and it's going to be minus 2 over y minus 1 y plus 2. And then what I want to do is then see, does this factorise? Now it does factorise because a common denominator, a common factor is 2. So I've got 2 lots of y minus 1 over y minus 1 y plus 2. Again, this is the reason why you do not expand the brackets in the denominator, because you should be able to find here that I've got y minus 1 both on the top and the bottom. Now I can cancel those down, leave me with a final answer of 2 over y plus 2 plus y. Or y plus 2. And there we go. Now moving on to question 8, let me just create a little bit of space. So looking at question 8, I'm going to be multiplying this first fraction by the second denominator, which is 3 plus b, and I'm going to multiply the second fraction by 1 minus 2b. I'm going to be multiplying the numerator and the denominator. So what this then becomes is 6 lots of 3 plus b over, and it's going to be 1 minus 2b, 3 plus b, minus, and it's going to be b lots of 1 minus 2b over 1 minus 2b, 3 plus b. Now again, looks very messy, so what I'm going to do is I'm going to keep the numerator, let's just join them together. So I've got 6, 3 plus b, minus b, 1 minus 2b. Yeah, it's definitely worth making sure your b's don't look like 6's. And again, keeping the numerator, also show the denominator in its factorised form. So now what I'm going to do is I'm going to expand my numerator, switch to a different colour pen. So here I'm going to end up with 18 plus 6b minus b plus, it's going to be 2b squared over 1 minus 2b, 3 plus b. Now simplifying the numerator, what I end up with is 2b squared plus 5b plus 18 over 1 minus 2b, and it's going to be 3 plus b. So moving on to question 9. So again, looking at the two denominators, we can see that they're both different. But one thing I do notice is I don't need to multiply both the denominators or both the fractions. Here all I need to do is multiply this second fraction by y minus 2 y minus 2. So then what that then becomes is 3y plus 1 over y minus 2 squared plus y lots of y plus 2, or y minus 2 rather, over y minus 2 squared. And then joining the two numerators together because the denominators are now the same, so I get 3y plus 1 plus, and then now if I expand it out, y squared minus 2y over y minus 2 squared. And simplifying the numerator, I end up with y squared minus or plus y plus 1 over y minus 2 y minus 2. And then all I've got to then do is just check, does the top factorise, in which it does not, and which then that there would be my final answer. Now looking at question 10, again what I need to spot here is that this here is a difference of 2 squares, so that there is basically w minus 1 w plus 1. So the only thing I need to add is this w plus 1 to the second fraction. So what that then becomes, if I multiply all of this by w plus 1 over w plus 1, And what I end up with is w over w minus 1, w plus 1, minus, and it's going to be w plus 1, w plus 1, over w minus 1, w plus 1. And then joining the simplifying the numerator, I get w minus, and then expanding this out, I get w squared plus 2w plus 1 over w minus 1, w plus 1, and then simplifying the top, I get minus w squared minus 1w, and because I'm going to be 1 minus 2, or 1 minus 2 it's going to be, which just gives me minus 1, and then minus 1 over w minus 1, w plus 1. Now with this, all we've got to do is see, can we factorise the top? Well, I just put this little here. Here we've got minus w squared minus w minus 1. If I take minus 1 out, I get w squared plus w plus 1. That doesn't factorise, and so there's nothing I can really do with that. So that therefore means that this here would be my final answer. Now finally, looking at question 11, we've got something that looks a little bit very messy. Now one thing I would recommend that you do here is try and factorise these two expressions. So looking at this, x squared plus 5x plus 4 can be written as x plus 4, x plus 1. And looking at this denominator here, I've got x squared plus 7x plus 12 can be written as x plus 4, x plus 3. So all I need to do is multiply this first fraction by the one that's different, which is x plus 3, and multiply this second fraction by x plus 1. So what we end up with then is something that's going to look very, very messy. So I'm going to end up with 1 and then x plus 3 over x plus 4, x plus 1, and then we're going to end up with x plus 3. Let me just neaten up that, because it looks like a rogue symbol. Plus, then I'm going to end up with 1 lot of x plus 1 over x plus 4, x plus 1, and x plus 3. And then simplifying the numerators, I've got, or expanding it out, so here I've got x plus 3 plus x plus 1 over x plus 4, x plus 1, x plus 3. And again, simplifying the top, I get 2x plus 4 over x plus 4, x plus 1, x plus 3, and which I then can factorise the top, leaving me with 2x plus 2 over x plus 4, x plus 1, x plus 3, and then just check, can I cancel that bracket, any of the brackets? No, I can't, so that there is my final answer. Now the key thing to remember is that not everything can be simplified. More often than not it can be, but not always. So it's always worth checking. So you may think to yourself, I've done some unnecessary factorization of both the numerator and denominator, but you always want to check to make sure that things don't simplify even if you do factorize them. So it's always worth going that extra mile because it could cost you a couple of marks. Now we'll put some practice questions in the description below for you to practice everything that's covered in this video, and also include the answers so you can check to see if you get them right.